Welcome to Ibid Press. Having looked at the random movement of balls or atoms and molecules in a gas, we're now looking at what will happen if we give the balls some energy and force them to be stationary. This is very much like a liquid solidifying. Now we force the bottom row of balls into a straight line. You can see that there are areas where we would have what would be called faults in our pattern, but there are areas, which I've just indicated there, where the pattern is quite clear. And what the balls are trying to do is get as close to each other as possible. As you jiggle it, you would expect more disorder to creep into this, but in fact, what I've just shown you there is the more you disturb the pattern, the stronger it actually gets. And we've still got some of these faults, these flaws in the crystal, but the area in which the pattern has formed up is much bigger. Now you're probably saying that this pattern results from the fact that the bottom line was straight. So we're now going to repeat the experiment with this wavy bottom line, and you'll see that when the balls come in, they are of course constrained to follow that bottom line. So we have an unpatterned bottom, but you can see that as the balls come in, they are again beginning to form up into this pattern which is known as close packing. So along the bottom here, we're following the curvy unpatterned base, and we have plenty of these flaws, but there are areas in which we've got the close packing pattern. Now what we're going to do now is we will again jiggle the whole thing around, which you would expect would decrease the amount of patterning. But in fact what happens is the number of flaws goes down. They're still there, but we have a much bigger area now of pattern.